Are humans facing a crisis with no cure? Even colds, toothaches, or infections could be fatal. Not stronger bacteria, but failing antibiotics. The WHO predicts that by 2050, 10 million people a year could die from resistant infections. That would be more than cancer. What if one day a tiny cut could kill you? What would we do? Dr. Zhang Geriatrics, and we'll talk about how antibiotics came to be, how tough those superbugs really are, and how to face a future with no drugs. Before we start, give us a quick tap and subscribe to Team Health. Use science as key to unlock a long, healthy life. This June, an ordinary-looking infection case turned into a doctor's nightmare. A man in his 60s was admitted for gastrointestinal bleeding, but later developed a liver abscess. 3 hospitalizations in 3 months, switched to 6 or 7 antibiotics. The team tried every option available, but every time it seemed controlled, it came back soon after. In the past, just the right antibiotic would stabilize this in a week or 2. So why was this case yet so hard to treat? When the blood test came back, we found multi-drug-resistant enterobacteria producing MBL, or metallo-beta-lactamase. What is MBL? It's a bacterial enzyme. It breaks down almost all beta-lactam antibiotics, from common drugs like penicillin, cephalosporin, to near-final carbapenems. No giving up. It's like scissors that cut apart the core structure of antibiotics, left the doctor with nothing. Our weapons against bacteria, from common drugs to last resort ones. And this isn't rare. It's the reality we face across healthcare. From cholecystitis to UTIs and dental surgery, with antibiotics you or I could run into a drug-resistant bug. In less than a century, how did we end up with failing drugs? To understand this, we need to go back to the birth of antibiotics. If we rank the 20th century's most destiny-changing invention, antibiotics would be at the top. After all, without them, knife wounds, pneumonia, and postpartum infections were almost a death sentence in World War II. Penicillin saved countless soldiers during the war. Back then, soldiers called it God's drug because for the very first time in history, infection wasn't fate. It was an enemy we could defeat. It worked so well that we treated it like a cure-all. In clinics, it was prescribed just in case. Patients skipped doses or threw them away. It was even added to animal feed for years. All this misuse, plus drug development that can't keep up with mutations, means that, without realizing it, we've helped bacteria evolve. What doesn't kill it makes it stronger. Not just in Taiwan. This crisis is global. A 2022 study in The Lancet found that in 2019 alone, more than 1.27 million people died from drug-resistant infections. If indirect deaths are included, the total will soar to 4.95 million, more than AIDS and malaria combined. The WHO also predicts that by 2050, nearly 10 million people a year could die from drug-resistant infections. That's close to cancer's death toll. They even listed 6 major drug-resistant threats. You may not know their names, but they're familiar in hospitals. Now they've become our toughest enemies. To fight this crisis, Taiwan launched a 5-year, $60 million program to slow resistance through surveillance, stewardship, and drug development. Hospitals have pushed countermeasures to the limit. Beyond first-line antibiotics needs strict review. If you have a drug-resistant infection, you'll be isolated. Staff going in and out must gear up fully, all to avoid creating stronger bacteria. What exactly makes bacteria so strong? Are they more toxic, or do they spread faster? Neither. Superbugs aren't super because they're more lethal. Their power is survival. Bacteria meet antibiotics. Like a natural enemy, superbugs, different. Not just aggressive, they've learned not to die. Each newly created antibiotic is like inside our ecosystem, triggers selection. Unprepared bacteria get wiped out, but some always survive. Then they reproduce into unkillable veterans. This isn't random. It's 80 years of human-bacteria co-evolution. When we met such bacteria, we'd try swapping out our weapons to take them down. As said before, from pistol to cannon until no weapons are left. But some bacteria get tougher with each attack, eventually becoming resistant to nearly everything. So it developed multi-drug resistance. Multi-drug resistant, MDR, bacteria. Even worse, these bacteria share their resistance blueprint. In biology, horizontal gene transfer. Horizontal gene transfer. Unlike humans, they don't have to wait for offspring to pass genes. Yeah, no waiting. Bacteria share intel in real time through conjugation, transformation, or transduction. They pass resistance genes to other bacteria, underground market style, trading bulletproof vests with each other. Worse, this kind of exchange isn't limited to the same species. Even completely different species can still trade what they need. So you may see a gut bacterium that used to stay in its lane can suddenly, by the next day, resist all. That is, this bacterial progress isn't individual evolution. It's a group upgrade. While we keep switching antibiotics, they've already built up over time. Weapon sharing. And they spread closer than most people realize. Hospital wastewater, farms, even your own body, all can be black markets for bacterial trade. If bacteria can share weapons, do we still stand a chance? Can we develop drugs faster, or just stand by and watch antibiotics fail one by one over time? Just when everyone thought the fight was hopeless, a new ally appeared. That ally is AI. Developing a new antibiotic used to take a decade and cost billions. The irony: once a drug hits the market, doctors are told to prescribe less of it to help slow bacterial resistance. For drug companies, this is a business that loses more when it succeeds. That's why in the past 30 years, fewer than 10 new antibiotics have been approved. AI changed the game. In an article published in the journal Cell in 2020, an MIT team successfully used AI for deep learning. From over 100 million virtual molecules, they found a compound that kills multiple drug-resistant bacteria in lab mice. Halicin. If this drug passes human trials, just in the US alone, it could save over 10,000 lives a year. But AI isn't magic. The molecule the computer finds is still just theoretical. To make it an actual drug, it has to go through cell studies, animal studies, safety tests, efficacy tests, human trials, and long-term monitoring after release. So this AI technology isn't a drug-making machine. It's more like a co-pilot. It can show us the way, but humans have to take the wheel. Aside from developing new antibiotics, is there another option? Here's the secret. We still have one last hidden card: phages. Sounds like a bio-monster, right? But it's actually a virus that eats bacteria. Even before antibiotics, doctors had found that viruses could kill specific bacteria. They were even used to treat wounds, dysentery, and more. But then antibiotics came along. They were faster, cheaper, more stable, and more effective. So phage therapy was sidelined for nearly half a century. Until recently, when antibiotics started failing, medicine finally remembered this forgotten killer. If antibiotics are bombs, phages are snipers, precise and adaptable, maybe the only weapon. Weapons as fast as bacteria. Recently, phages have returned to the clinic. In the US and France, patients with untreatable superbugs were ultimately saved by phages. Skin infections. Infected artificial joints. When the strongest antibiotics fail, phages are our last hope. Taiwan is doing research. NTU and the CDC are building a phage platform for monitoring and treatment. So when severe infections strike, one more treatable card in hand. But phages, not yet standard. We must tailor to each superbug. We must tailor each dose. Hard to mass produce, hard to approve. But attitudes have shifted. We used to just blindly kill bacteria, but now we must learn to coexist with them. From AI to phages, we're learning how to use science to negotiate with microbes. Nature's gifts are all beautiful gifts from heaven, including bacteria. Without them, we wouldn't have bread, wine, or cheese. Our gut holds 10 times more bacteria than our own cells. Against harmful bacteria, is using stronger, broader antibiotics to wipe them out our only choice? Or, when we look at it from God's perspective, would we see it differently? And when was the last time you took antibiotics? Share your thoughts in the comments. And tell us how you see this tug of war between humans and bacteria. If you want more medical advances, keep watching our show. Please subscribe. Join Team Health. Let's stay healthy together.